Welcome back. My name is Luc de Koster, founder of the Koster Academy. Welcome to my YouTube channel. Do not forget to click on the subscribe button, click on the bell button, and every time we have a new video, you will be informed about it. In this new video, I will talk about the calculations of the percentages for the normal distribution as we did before when we looked at a table, but now we're going to look at what is possible when you have a spreadsheet program or some specialized software that can provide you that information. I'm referring here to Excel, but there may be other programs and other ways. Now, we have two ways in Excel to do the calculation. We can use what we call the normalized formulas, and here we're going to use the Z value. And we find, in fact, the calculation in Excel is providing you the surface left of the Z value that you selected. Now, the formulas are quite simple. There are some parameters. The first one is NORM.S.DIST, which refers to the normal distribution, but standardized. That is why the letter S is there. And we have two parameters here, Z and cumulative. Cumulative is a parameter we can set to true or false. So Z is the calculated Z value. So when you're using this formula and you have the average X and the standard deviation, you first have to calculate the Z value. And typically we are not interested in the Z values, but we're interested in the X values. That's what we want to know. So in this case, first calculate the Z value and then put it in the formula and find the surface. The cumulative parameter provides two possibilities. We can find the cumulative curve, so we find the gray surface, so the integral of the density curve, or when we put there false, we find the value of the density curve at the Z value. What we are doing most of the time, we're looking at the percentages. So typically we will use there the cumulative curve, and the density curve, well, we can draw, for example, the density curve for different values of Z going from -3 to +3. We can draw this curve basically perfectly. So that's one way to calculate the surface. In Excel, we always get the gray surface, so everything smaller or equal to Z. The classical formulas, or when we don't want to calculate the Z value, we can find the surface starting from the values X, mu or X bar, and sigma or S. So basically we have in fact the calculation of those parameters. Now we don't have to calculate the Z value. We can automatically calculate the surface, and that's thanks to the computer. We can put in these parameters and the computer does all the calculations for us, and we don't have to calculate the Z value. So that's an advantage that we have today. We don't have to calculate the Z value. It is possible to calculate the Z value, but if we have the parameters, the raw parameters X, mu, and the standard deviation, we can use the formula immediately. We have more parameters to add to the formula, and the formula has a different name. It's NORM.DIST. The S is not there anymore because it's not a standardized normal distribution, and we have the parameters X, which is the data value that we want to consider. We have the mean and the standard deviation, and again we have the parameter cumulative, which is true for the cumulative curve and false for the density curve. So basically that's the way how we can use the Excel formulas to calculate these formulas, to do some calculations with them, and we will have some examples how to calculate specific surfaces and to resolve some specific problems. That was all about the calculation using Excel. Of course, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. I thank you very much, and I'm looking forward to seeing you in our next video. Thank you, and bye-bye.